In the previous lesson, we learned about molecular formula and the empirical formula. Molecular formulas are like this top line here. They tell us exactly how many atoms are present in a compound and which type of atom. So here we've got two elements in this compound, carbon and hydrogen, and this molecular formula tells us that there are 2 atoms of carbon with 4 atoms of hydrogen. Again, nothing new for us there, but the last day we learned that the empirical formula is kind of more historical. It came from experimental evidence, and it was basically where scientists worked out what was the basic ratio, or this lowest, simplest ratio of the different elements in a compound. They couldn't find out exactly how many atoms are present, just what's the ratio of the elements in the compound. So you can think of this as find the lowest common multiple of the numbers in the formula, and that's going to be your empirical formula. So say, for example, if we can divide both of these numbers by 2 to give us C1H2, which is the empirical formula here, CH2. We can divide both of these numbers by 3 to give us C1H2 again, same empirical formula. Divide both of these numbers by 4 and so on, and you see how that works. So empirical formula just tells us the elements that are present and what ratio they're present in it. Okay, in today's video, we're going to learn about how we can work out the empirical formula when we're given the reactant masses when a compound is being formed. Sorry, my screen is jumping all over the shop here today. Let me figure out where we're at. Yeah, okay. All right, so what we're going to do is we are going to do 2 examples. I'm going to do one, and then you're going to do another one side by side. So what I'll get you to do is take down this green bit in heading here as a heading. So we'll calculate an empirical formula when you're given the masses of reactants and products. So I want you to just take that down as a heading at the top of the page. Pause the video, do that now. Okay, so once you have the heading down, what I want you to do is split your page down the center. So exactly a line down the middle, and you've got a left and a right hand side. Pause the video and do that now. All right, on the left hand side, I'm going to do my worked example, and you're going to take it down when I tell you to, and then you're going to apply what you've learned to do a second one. Okay, let's take a look at the problem. What are we faced with? It says that when 127 grams of copper combines with oxygen, 143 grams of an oxide are formed. What is the empirical formula? So you see how this relates to the heading. We're given the masses of the reactants and the products, and we're asked to find the empirical formula. Okay, so don't start writing anything yet, just watch and I'll tell you when to stop and take it down. The first thing I would do here is start by trying to write down some kind of an equation to describe what's going on here. So we're reacting copper and oxygen. So in a chemical equation, I would write this like this: copper plus oxygen. And let's go back to the blurb. What does it say? When copper combines with oxygen, an oxide is formed. So we're forming an oxide. Now, you could just write an oxide, but most of us will understand that if it's copper and oxygen that are reacting together, it's copper oxide is what's formed. The names aren't really too important here. It's just for us to have a big picture in our head of what's going on. The next thing I will begin by doing is start writing down what I know. I know I've got this amount of copper. So underneath my copper here, I'm going to go ahead and write down how much I have. I have 127 grams. What else do I know? I know that I made 143 grams of the oxide. 143 grams of the oxide like this. Now I don't know the oxygen because it doesn't say it in the question, but I am going to have to figure it out. So after I've done that, I'm going to summarize what I know, just making a list down the side here by writing down the masses that I know. Mass of copper oxide, and I should be able to work out the mass of oxygen then. So I'm going to go ahead and I'm going to write down what I know. I know my mass of copper is 127 grams. I know my mass of my copper oxide is 143 grams. So how can I work out the mass of my oxygen? Well, it's got to be the rest. If this much is copper and this is the final mass, well, the rest had to be the oxygen because it's the only other thing here. So what I would do here is I'd take my final mass, 143, and take away the mass of the copper, 127 grams, and that's going to give me the mass of the oxygen. Go ahead, stick that in your calculator. You're going to get 16 grams. Okay, so what we're going to do is we're going to take this idea. I'm going to ask you to pause the video. On the left-hand side of your page, I'm going to ask you to write down everything that's here, including the question, so that you have this to refer to when you go back. So write this down as the question, and then take this down as the example. We're not finished yet, by the way. We're just going to do it step by step. So pause the video, take that down. Okay, so what we're going to do now is we are going to apply what we just learned. Here's our line down the middle of the page, and we're going to work on the right now. You're going to work on this problem. So step by step, we're going to do that first bit that we've done here so far. Okay, so I'm going to help you step your way through this one. Let's see what it tells us here. It says a 17-gram compound contained 4.6 grams of Na, which you should know is sodium, 2.8 grams of N, which is nitrogen, and the remainder is oxygen. Find the empirical formula of the compound. That's what it's asking us to do. Okay, so what we want to do is begin by what I did before. Try and write down some equation that describes what's happening here, some chemical equation, word equation for this. Go ahead, pause the video so you can write it down. Okay, so what you should have done is you should have started by writing down what's being added together. We're adding Na, N, and O. Okay, now I would always begin by writing those element names. So Na is sodium plus nitrogen plus oxygen react to give this compound. Now you could go ahead and just write compound here because the name right now isn't that important. But some of you more eagle-eyed people might know what this compound is probably going to be called. We've got sodium, nitrogen with some oxygen in there as well. Now I've never heard of sodium, nitrogen, oxygen or anything like that. Sodium, nitrogen, oxygen, that doesn't make sense. But some of you may know what that's called, okay, or have an idea of what that might be called. All right, so a good, if you've had a go with it already, a good probability here is that this is going to be called sodium, and then we're going to have nit. And generally, we've got stuff with oxygen in it, it's called nitrate. Okay, so it's probably a good guess at what this substance is going to be called, but like I said, it's not really that important. The next thing is underneath this, go ahead, write down the masses that we know under each thing. Pause the video, do that now. Okay, so hopefully what you've written is that for the sodium, we had 4.6 grams. So I'm going to put that up here, 4.6 grams. The nitrogen with 2.8 grams, and the compound we know was 17 grams. So now we're going to summarize that. Okay, so I'm going to write down the outline of the summary, and you're going to go ahead and work out what each one is. So we've got the mass of Na, got the mass of N, got the mass of the compound. Lastly, we're going to need to know what the mass of the oxygen is, this blank here. So we're going to need to know that mass of O. Okay, so what I'm going to do is get you to pause the video, write down everything, make sure you do have the question at the top, write down the outline and work out what each of these is equal to. Okay, so you should only be playing if you've had a go at doing this. Again, there's no point just watching me doing it because that's not really going to help you learn it. You have to have a go at yourself. If you get it wrong, who cares? You'll see it. The right answer in a second. So Na is 4.6 grams. That's the first thing, 4.6 grams. Nitrogen is 2.8 grams. The compound, the whole compound is 17 grams. And that must mean, okay, well, if the compound is 17, we have the masses of these two together. The rest must be oxygen. Now you can go ahead and do the mass of these two together up here right now, or you could just kind of write an equation for this. An equation might look like this. The mass of oxygen is equal to 17, the takeaway, and then the masses of the other two. And you've got to do these in brackets like this, 4.6 plus 2.8. Alternatively, you can go ahead and add them together up here and then just put that in the equation. 4.6 plus 2.8 equals, so together these equal to 7.4. So you could have just done that there and then stuck this down here. It's up to you which way you want to do that. But when you work that out, you should get 9.6 grams. So the oxygen is 9.6 grams. Okay, so you've completed this now down as far as where I had done on my example. So you should be confident, nothing too difficult there whatsoever. So I'm going to go back to my example and we're going to learn how to finish it off. Now, what we need to do is we need to compare the ratio of copper to oxygen in this compound. And we've got to do this by comparing the moles of copper to the moles of oxygen. We don't compare them based on grams because the grams of copper and the grams of oxygen, they weigh different amounts. So we've got to first convert them to moles and compare the molar ratio of these things. So how many moles of copper to how many moles of oxygen? That's what we need to figure out. And generally in chemistry, you don't ever compare grams of things. You always compare how many moles of this to how many moles of that. So good rule of thumb, always compare things in terms of moles. So in the compound are two elements. So this is what I'm writing down here, is copper to oxygen. That's what we want to know. What's the ratio of copper to oxygen in this compound? To work this out, what we're going to need to do is we're going to need to take the masses of each one. The mass. Okay, so I'm going to go ahead and write down the mass of each thing. I know that, I've worked it out up here. My mass of my copper is 127 grams. Up here, look. My mass of my oxygen is 16. I can work that up here, 16 grams. Now that's comparing them in terms of mass, and that's not what I want to do. I want to compare them in terms of moles. So what I'm going to need to find the moles of each one of these is I'm going to need the MR, and moles equals mass divided by MR. So that's what's going to happen here. I'm going to do mass divided by MR of each of these things. So MR of copper, I'm going to my periodic table, and I'm seeing the number 63.5. Now your periodic table might round that to 64, and then you're going to get a slightly different answer to me. I'm going to go ahead and use the more accurate 63.5. And then we've got oxygen's atomic number, or sorry, mass number is 16. So when we go ahead and find the moles of each of these things, what we're going to get is 127 divided by 63.5 equals 2. So 2 moles of copper to 16 divided by 16 is going to be 1 mole of oxygen. So now we've got the molar ratio of copper to oxygen in the compound. There's one last step really that we might have to do, and we don't have to do it in this case. If this isn't the simplest lowest common denominator of these two things, then we'd simplify it. So if it was 4:2, I would simplify that down as 2:1. In this case, 2:1 is as simple as I can get in whole numbers. I could go 1:0.5, but then I have something that's not a whole number. So that's not really simplifying it. So the last thing then is to think about what the formula is. So the empirical formula, we call this the empirical formula, tells us the simplest whole number ratio. It tells us that there are 2 Cus, Cu2, and 1 O, Cu2O. That there is the empirical formula of this compound. All right, so let's take that idea. So I'm going to give you a chance to pause and take that down. Okay, so you've taken that down, and now we are going to apply that to our idea over here. So this time we have 3 elements in our compound. So I'm going to lay out the structure of this for you so you know what it looks like. We have 3 elements in the compound. We have Na is to N is to O. And we want to know what's the simplest molar ratio between these three things. So the first thing you're going to write down is the mass of each one. Then you're going to find the MR of each one. Then you're going to find the moles of each one. Then you're going to find the ratio. What's the ratio? And then you're going to find the molecular formula. And to find the molecular formula, you need to make sure that this ratio is in its simplest form. Simplest form. Okay, so I'm going to give you an opportunity to pause the video and try this by yourself. There's no point in me showing you another one. It's time for you to have a little go. If you get it wrong, that's okay. Now's the time to make a mistake before you do some practice on a full question by yourself. So pause the video so you can have a crack at this now. All right, so the first thing we want to write down is the mass of each thing here. So the mass of sodium we have is 4.6 grams. The mass of nitrogen we had was 2.8 grams. And the mass of oxygen that we had ended up being 9.6 grams. The MR of each of these things, you've got to go to your periodic table. And of course, we're going to divide the mass by MR in each case to give us moles on the next line. So the MR of sodium is going to be 23. The MR of nitrogen is going to be 14. And the MR of oxygen is going to be 16. So now we've got a way to turn mass into MR. Turn mass into moles. We divide by the MR, and we're going to get moles on this third line down here. So this is where we're working at now. If you didn't know what to do there, pause the video and get the moles for each one now. So 4.6 divided by 23 gives you 0.2 moles. So 0.2 moles of sodium and then we've got 2.8 divided by 14. 0.2 moles of nitrogen is to 9.6 divided by 16. 0.6 moles of oxygen. Now, to get the ratio, well done if you got that line right. So to get the simplest whole number ratio here, what we want to do is we want to take each of these and divide by whichever of these three numbers is the smallest. That will give us the ratio. So 0.2 is the smallest number. So what we're going to do is we're going to divide each of these things by that smallest number, 0.2 divided by 0.2, and this should give us a whole number ratio. So if you want to write down here that what you need to do is divide by the smallest number. Now, in the first example that I did, this wasn't necessary as we already had a simple whole number ratio. But in this one, you did have to. So you divide by the smallest number that you got on this moles line. So we're going to get 0.2 divided by 0.2. And again, you should know that Anton divided by itself is going to give you 1. So the ratio here is 1 is 2. And that's the exact same. So that's going to be 1. And then on this line, if you do this one, go ahead, pause the video and do it. Some of you will be able to do it in your head. 3. Now, so 1 is to 1 is to 3, and that is a simple whole number ratio, okay? You can't make this any simpler. There's no lowest common denominator here. Well, there's no common denominator that makes these any simpler, keeps them whole numbers. So what's the molecular formula? Well, there's 1 part Na, so Na. There's 1 part N, N, and there's 3 parts oxygen, so O3. So that there is going to be your, that's not your molecular formula, sorry, that's your empirical formula. Empirical formula. Right, so that there is how you work out the empirical formula when you're given the reactant masses. So what I've got for you guys to do now is I want you guys to do the, oh, by the way, this here is just the same thing as I've done. It's an outline. It's a bit neater and tidier because it's all in a table, but if you look through it, if you need to see it again, you'll see that this is exactly what we just did. This is the full example that I did, and then this was the outlined example that I helped you with. And then you guys are building up to doing these 3 questions by yourself now. So what I want you to do is practice these 2 questions, 21 to 23, complete those, and we'll go through them in the next class and check your answers out. They should be all very similar. Just follow the process, get confident at doing them, and that's it. We'll see you in the next video.